Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can throughout the webinar. Also, after today's webinar, we are going to make the slides and a recording of the event available on demand, as I said earlier. And at the end of today's webinar, we are doing something special today, courtesy of the fine folks at Red Hat. We are going to be doing a drawing for 6 $200 Amazon gift cards. So please stick around. Hopefully you'll be one of our 6 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Data Management for Multi-Cloud. Our speakers today are Jim Walker, who is the Vice President of Marketing at Cockroach Labs, and Stefan Mattis, who is the Senior Solutions Architect at Red Hat. Gentlemen, thank you so much for joining me today. Really appreciate it. Jim, I'm going to turn it on over to you and let you introduce yourself and kick off the webinar.
Wonderful, and thank you for having us, Charlene. Again, good morning, good afternoon, good evening to everybody, no matter where you are on this great planet. I'm in beautiful New York City today. It's warm. It's hot and sweaty in New York City today. But I really wanted to welcome, before I introduce myself, Stefan as well. So Stefan, welcome to the webinar. Where are you dialing in from today?
Thank you, Jim. I'm dialing in from Toronto, Ontario today, which is nice and warm and toasty as well.
Yeah, hey, we still have a hockey season going on. So, hey, I'm sorry to just think hockey when I think Canada, but you know, it's still going on. Stefan, what is your role at Red Hat, just so the audience has a better sense of who you are and where you're coming from?
So my role at Red Hat is essentially a solutions architect, which is the guy who is asked every question about everything that Red Hat has in its portfolio. My client base happens to be in the financial sector, so I tend to take care of bank questions and how banks organize their technologies. I am essentially the go-to guy when it comes to understanding technology and making it a clear option for pretty much all of our clients.
Yeah, that's awesome. So interesting coming with financial services clients. I think it's applicable across lots of different industries. I was having a conversation with somebody yesterday. Are banks or are they tech companies today?
Well, actually, that's always been a question. I would say that they're tech companies, but unfortunately, the regulations that they are dealing with quite often limit their ability to just do anything they want. So there are challenges that come from regulations, and that changes their outlook quite a bit.
Yep, that's right. But they function a lot like tech companies, and I think a lot of the lessons, a lot of things that we're seeing in financial services, and some of the questions you're getting into, the conversations, I think are applicable really across the board, really in lots of different organizations. I think similar challenges, and I hope that's what we present to everybody today. My name is Jim Walker. I am VP of actually product marketing, not all of marketing actually. I like the product marketing side. It's, we get to translate these really deep technical concepts into English and help everybody kind of understand. And so, my role today is, is participant, is not just as a moderator. And I hope that the conversation that Stefan and I have is compelling enough for you to stick around for the whole session. I think we pulled together some pretty good material. Hopefully it's valuable. Regardless, there's still a $200 Amazon gift card at the end as well. So if we aren't entertaining, then I hope you still stick around for at least that. But I promise we will try to be entertaining, right? So before I get started, there's like a dark partner here. There's like one looming voice that is on everything I do with Red Hat. And it's my friend Mike Waite. Mike, do you want to come in and introduce yourself and just talk a little bit about Red Hat and the partnership here?
Yeah, sure, I do. And by the way, Jim, one other thing, we're giving away 6 $200 Amazon gift cards at the end.
You got to stick around.
You got 6 lucky winners. Yeah, I just wanted to come here and say, you know, the reason why we do these types of things with Cockroach Labs is it's not just by random. It's not because we like the name of the company better than some other company, but they have a cloud native database which is tried, tested, trusted, and certified through the Red Hat certification process for customer production use on OpenShift today. And that's really what is going to allow customers to say, okay, hey, we can feel good about moving this into a production environment. We can get it out of the test and development environment, and we know that we can use this to solve real world business problems. So it's not by mistake that Cockroach is here doing this webinar with us. It's because their business applications are fully supportable and ready to go on OpenShift today. Jim, back to you.
That's right, Mike, and thanks so much. You know, I love partnering with Red Hat. Actually, I was at a company called CoreOS, so a lot of my old company is part of Red Hat now, and actually part of what we're going to talk about here today in OpenShift. And you know, I joined Cockroach Labs probably about a year and a half ago, just because I saw some of the challenges that people had around Kubernetes and around kind of distributed systems and the challenge of data in that context. And so, you know, the webinar today is about data management in these distributed environments and how OpenShift and CockroachDB, Cockroach Database, can actually come together to help you. And you know, certification is really important for our customers as well, because a lot of people are going down the path of Red Hat and they're using OpenShift and they trust them. They're open source, they get it, and they want kind of one solution that is kind of going to ease their adoption and their path forward, because really none of this is easy. Ultimately, I think, you know, we're going through a paradigm shift in terms of the way that we think about systems, the way we think about our applications. I mean, we're breaking them down into services, right? You know, we're deploying them on orchestration layers. I mean, the orchestration layer, who ever even heard of the term 2 years ago, right? Okay, maybe some of us, you know, but really honestly, like the introduction of Kubernetes, the introduction of distributed systems has lots of benefits. It's allowing us to take advantage of cloud infrastructure in ways that we just weren't able to before. If you look at the advent of these technologies, it's really out of the last 10 to 15 years at huge, massive companies like, well, where did Kubernetes come from? Google. You know, they lived in that future. And so how do we bring this sort of technology and how do we bring that sort of scale to everybody? And not just the scale part, how do you make it easy? And I think that's the biggest challenge. And that's why I like working with Red Hat. They're just really great about understanding developers and understanding DevOps and SREs and how to make their lives easier. For us, it's about data, and it's about the application layer, and it's about making the database real easy in these environments like Kubernetes that is very unique. You know, distributed architectures present significant challenges for legacy databases. Are you going to set up a monolithic database and have, you know, all your systems across the whole planet access that? Well, there's a little thing called the speed of light, and, you know, how do you actually get past that, right? And so lots of challenges which can be solved with a distributed database, and that's what I want to talk about today. But before we get into that, I want to talk a little bit about just to level set before Stefan and I have a conversation about how people are using this kind of architecture together. A little bit on Kubernetes and OpenShift and how it aligns, and a really simple explanation of it, so that I can actually lay in how Cockroach actually lays in on top of that, and why this is, you know, peanut butter and chocolate, right? You know, Kubernetes was really kind of, it's Google exhaust. It's, you know, the back end of Google, you know, Mail and Drive and everything is just running off of something called the Borg. Well, they open sourced a version of that. Really, it's kind of a V2, and there's a very clean API built around something called Kubernetes. And Kubernetes has been around for, oh gosh, I think it was the 5th birthday just recently, right? And so
that's right.
It really, go on, Stefan.
No, that's right. That's exactly it. We're actually now seeing the point where this is a technology that has been around long enough that soon it's going to be considered to be a standard behavior.
I think it already is, but I also live in this world, Stefan. So
yeah, that's true. I live with bankers, so it's a little more conservative.
So Kubernetes, like you know, like Google had to scale the whole planet, and they weren't able to do that from day one. They had to actually build this stuff out. And so what Kubernetes is really allowing organizations to do is just basically scale applications up and down with ease. Make sure that applications from, you know, the core, you know, the one of the cloud native principles or primitives is to basically architect things for scale and architect things for resilience. They can scale up and down very easily, and they're just always going to be there, always going to be on. And I think that is basically the core of the definition of kind of Kubernetes. It is unique. It does present some challenges though. What happens when you're hybrid cloud? What happens when there's like this jurisdictional control over compute in different data centers? How do you deal with data in these environments if you're going to do this? Quite honestly, setting up 2 Kubernetes clusters and having them all work as one, difficult, right? And so I think it's kind of one of these things that, there are some unique challenges that are presented by this. I think there's some unique value, but there's definitely, some very unique challenges that are going on out there. So to have a conversation about Kubernetes and to understand what that is, we gotta reach back a little bit further and go into what is a container. And really a container is the core kind of like, if you think about a foundational element in which all these kind of services-based things, I think everybody here is fairly familiar with containers and Docker and what's been going on, but it's just an abstraction of the OS so that an application can run anywhere. And so, for us, like Cockroach will run on OpenShift. We have a certified container that will run within that environment. It just makes it real easy for code and all of its dependencies to be packaged up and very cleanly and easily deployed within some environment. Now, in so doing, abstracting and doing these things, it's made it very easy for us to kind of create these small units that we can basically containerize and run them anywhere and deploy them very easily. And honestly, ultimately, with Kubernetes, orchestrate them, right? And so I think it's a key piece and it's just a key level of abstraction, really the core and the baseline of what this is. So what Kubernetes does ultimately is control these services. We use the word orchestrate, but if you really break down Kubernetes into the simplest version of what it is, and I've been trying to do this for years, is there's a control plane, like a brain, if you will, and then underneath each instance of an application or a service is a pod. And a pod basically allows it to communicate back with the brain, right? It's kind of like the Avengers, when all those things came out of that crazy spaceship, and the control plane had control over everything, right? A little bit like that, with less of the violence and less of the negativity, I guess. But still, control plane and pod is really kind of the core of that architecture. And I think that's, if you're going to break down Kubernetes into its core components, that is it. Now, what this does is control, like it allows you to basically do this. Now, Kubernetes itself is an API. It's fairly raw in its implementation. If you know Kubernetes, it's very powerful. But when you get into enterprise organizations like financial services and whatnot, right, Stefan? Right. Having a tool or having a packaged version of Kubernetes, of which provides even deeper extensions and integrations with current tools and great UI and support and services, that's where kind of Red Hat OpenShift comes in, right? Right? Isn't that right, Stefan?
That's exactly it. And not just that, in some ways, one of the #1 challenges with Kubernetes or anything that can scale is that from a day 2 perspective, you have to have people who have the tools to be able to see what's going on. I mean, it sounds wonderful when you have a control plane, but somebody still has to be able to understand what the control plane is, seeing, leveraging, modifying, seeing all the communication between the different pods, their current states and everything else. So in essence, what OpenShift is the smoother, more polished version of Kubernetes with all the trimmings that an enterprise customer needs. The ability to even just add users to Kubernetes. Would you like to create everything from scratch? No, you probably would like to leverage your existing AD directories or any of the kind of user informations that you have in your organization and fit it in. And fitting in something as wild as Kubernetes, which is a descendant of Borg, means that you probably will have to do some integration. Well, part of the whole OpenShift experience is that we've done an extensive level of integration, everything from logging to monitoring to actually adding all the pieces that, frankly, you would have to do by yourself. And that's the beauty of OpenShift.
That's right. And Kubernetes is one project amongst many, right? Within the CNCF and the Cloud Native Computing Foundation. There's a whole bunch of stuff that could actually come into that. Go on, Mike. Yeah. All right. So Red Hat OpenShift delivers Kubernetes in kind of an enterprise integrated way with lots of different things. I also want to just take a step back for 1 second, Stefan. You talked about integration with lots of other things. There's also the concept of an operator in
Yes.
Kubernetes as well. And I don't have anything on this slides about this, but I think it's actually a good opportunity to take back. Can you explain to me what an operator is and why that's important within the context of Kubernetes and OpenShift?
Absolutely. It's probably one of the largest improvements that we've seen. So operator is essentially, if I was going to dumb it down to the basics, it's taking the operational, the day two knowledge, the things that an application needs to have it done to. So like a database needing backups or any of those kind of tasks that usually are not part of the application but surrounded, and rendering it into code as well. And essentially taking knowledge that a person would have done and managed and turning into a ancillary piece of code. And the big thing about Kubernetes is these pieces of code are essentially gifted with the permission to do their work just on the application they're designed to like support. Part of that is also that it allows us to get partners such as CockroachDB to bring their tooling and essentially have the entire installation, maintenance, and lifecycle built into the tool. Essentially, once the operator is installed, it'll take care of upgrades, it'll take care of backups, etc. It's wonderful design technology.
Yeah. Yeah, and there's lots of people at Red Hat who have basically, you know, kind of originated that technology.
Absolutely.
The Rob Zoom of the world and the CoreOS guys. Yeah, I mean, it was, you know, I think we originally called them controllers, but we wanted to call them, you know, really what they were. And it's really kind of the automation of this whole like SRE function and how do you make it real easy to deploy a database? And, you know, so Cockroach Labs and CockroachDB has an operator that's certified operator for Red Hat OpenShift. Red Hat certifies these things so you know they're going to work out of the box, which I think is another key value of actually going down the path of either roll your own Kubernetes or, you know, go and grab something like OpenShift, which I think pretty easy and straightforward, right?
That's right.
So let me just finish up on one last thing here about kind of how orchestration actually works. And so I talked about there's this control plane and then there's these pods, right? And so really ultimately the way this works is there's a little thing in Kubernetes called etcd. You think about it as the brain. It's where you say, hey, I want these things running. So in this diagram here, you have blue, red, and yellow. I'm a little colorblind, but I think I got that right. And so that's a pod with a container in it. It looks, you know, it kind of looks like my diagram from before, right? And there's a bunch of servers. Say I have 6 servers in my cluster that are up and running. Well, you basically just tell OpenShift, it's like, hey, OpenShift, I want 10 instances of this blue thing. No, Kubernetes is going to make sure that 10 instances are up and running. This is where the operator comes in, right? If something special has to happen when I spin up one of these things, and you can actually codify that within the operator. Now that's all integrated with OpenShift, right? So now I can handle the scale of up to 10 of these services taking, you know, requests from say external users or from other applications. Maybe it's the get account thing, right? So I can also spin up other instances of different services as well. Now, when it's actually spinning these things up, you know, often it's not just a single server. There's lots of code that actually goes into that. Maybe there's some configuration files. You know, often it's
yep.
What's that, Stefan?
Secrets. So the number one thing is quite often you have multiple copies of things, but they might need things like passwords and things, and you don't want to embed them. So yes, there's quite a lot of pieces to this.
That's right. Yeah, secrets is a really good example, and certificates, right?
Yep.
And you know, so all that complexity is actually just handled. Now, can you imagine? Okay, so this is what do we have here? 26 different services across 6 machines. Imagine, you know, SSL into each one of these machines, spin it up, make sure it's all configured, make sure it's all connected. It's a nightmare. Like just to do all this work yourself. Imagine what that would take. Now, imagine what this meant for, you know, Google as they were scaling up Gmail. Thousands and thousands of instances of these things. And so that's really, it's the easiest way to think about this. Think about what it would do manually. You just basically just do this now. And it's basically coordinating this across all these different machines, which is just awesome, right? And so, you know, the other beauty of Kubernetes is you can do things like, well, I want to change the scale. So I just come in and I change. So I want 12 of these, I want 7 red, and I want to up the yellow to 10. And it goes and deals with this. Now, another really, that's just the ease of scale up, scale down. Simply set a number, the platform takes care of the rest. Now, often machines go down, and that's just the nature of the world. Everything fails, right? That is hardware. So what happens when things fail? And so I had these 3 instances, 2 red and 1 yellow on that machine. What does Kubernetes do? Kubernetes realizes, like, wait a second, I don't have all the instances up, so it spins them up on other machines. So you're always going to maintain some certain level, some SLA, if you will, across the various different machines. Do you want to throw something in there, Stefan?
Actually, I find that it's interesting to realize that both resiliency in this case of having the amount of applications available in the count and the ability to actually handle scaling are the same pattern. In fact, in some ways, having the machine that failed is the same as if you had fewer resources and you had to rebalance everything. And a lot of people forget the fact that in very good environments, very flexible environments, if you want to do patching or you want to actually take a machine and do some investigation on it or recertify a particular machine, in this kind of scenario, you could do this without the drama. You could technically tell OpenShift and Kubernetes indirectly to please empty a particular machine so we can do some work on it and then do the work and bring it back, essentially having a zero downtime kind of a behavior.
That's right. And think about that zero downtime, but also think about rolling upgrades, right? Like I can actually upgrade a service because you know what? I can actually instruct Kubernetes to say, okay, take down each one of these blue instances one at a time and spin up the new instance in the new version, right? So rolling upgrades become a reality. And we're talking about no downtime. Like no longer are you saying, okay, let's schedule this, outage at 3 a.m. on Friday night, which, I'm sorry, that's not fun.
No.
Nobody wants to do that, right? And so, and maybe you can actually try something on Friday afternoon, hey, why not, right? You can spin things up and down, and just managing that upgrade process is a huge piece. And so this is just across any sort of software. Now, if that's like servicing a machine happens, upgrades of services happen. So this just automates that, makes all that really kind of simple and fairly seamless. So where does Cockroach fit into this? So CockroachDB really presents a very unique distributed architecture. It's very similar to Kubernetes. Each node within a Cockroach database is the same binary, so I could spin up a node anywhere. I pointed at the cluster, and it's gonna take part in the database, and right. So I could spin up a node here on this laptop and point it at a cluster that's running in say, I don't know, any of the public clouds. And it's going to take part in that cluster of a database. It's going to look like one logical database, while physically it's actually living on different clouds. Or I could spin up 4 or 5 nodes in a single AZ, and it's all going to be one cluster. Now I don't have to do any sort of configuration that's special across any of those nodes, other than and I point them at each other. The database is going to take care of that. Now, if I wanted to spin up a new node and point it at that cluster, I'm going to do that. The database itself is actually going to rebalance everything. So it's going to take it and balance for utilization or for storage, right? And it's going to use heuristics to actually understand where data needs to live across different nodes within that cluster of the database. Now, if you think about this, how did you scale an instance of Postgres in the past? Well, you had to actually spin up a new instance. You had to do this thing called manual sharding. It's a nightmare. What happens when you want to actually scale it again? You have to actually set up another shard, you have to redo all of that. It's just really difficult. Now, databases have kind of learned how to deal with this, the manual sharding, but where it gets really interesting is on the resilience side as well. Does it deal with failure? Just like Kubernetes was dealing with the failure of a pod or a failure of a piece of compute, Cockroach can also just deal with that. It'll spin up and it'll move that data into nodes that are still alive. Which is kind of really beautiful in that it was also built on the same cloud native principles as Kubernetes, a single binary, architected for scale, architected for resilience, right? And so these are the kind of similar things. In fact, CockroachDB is actually a descendant of something at Google called Google Spanner, where Spanner is tied to Google hardware and was kind of was Google Spanner is to Borg as CockroachDB is to Kubernetes. Really, it really makes a whole lot of sense, right? The other beauty of CockroachDB is any one of these nodes can actually take a transaction. I don't have to go through a single write node. Every node is a read-write node, and every node can find data throughout the entire cluster, which is really, really kind of cool because I don't have any sort of monolith and performance bottleneck for writes, which we've seen in some other kind of quote distributed databases. So if I have nodes in New York, I have nodes in say Singapore, it looks like one big database. Users in New York can actually access the data there. Users in Singapore can access. So it all looks like all global latency is ultimately a local latency, which is also really, really beautiful. And in order to deal with that, we actually promote something. We have a capability called geo-partitioning, which allows us at the row level to tie data in a table to a particular location, which ends up being really, really cool as well, right? And so, you know, for us, Cockroach Database just fits in this Kubernetes world, in that it also is a distributed architecture. Go on, Stefan.
Actually, that your mention of Singapore reminded me that Singapore themselves have a rule that says that data related to financial industries has to remain there. So this would be ideal for that scenario.
That's right. And many customers use this for that exact reason, right? Like, you know, I still need to access that data from anywhere on the planet, but where it resides physically is in Singapore. We can do that at the row level. And actually we can do that and we can change that on the fly. It's just an alter table command. It's really literally a SQL command, right? I alter table and say, okay, all rows that have this as a country code live on these servers, and it's completely you know, configurable, and then people change it all the time to take advantage of that. And so we see people use this for things like GDPR compliance, that sort of thing, and exactly the same sort of thing that you're talking about in say Singapore, which is I just find to be really cool. And I've never seen that in the database. So no more manual charting, no more dealing with this kind of like best practice around data privacy and regulation. And then you know, deal with, you know, get local latencies even at global scale, all the while guarantee transactions. You know, you can do some of these sort of things with something like a Cassandra or one of these other NoSQL databases, but you aren't going to get transactions. You aren't going to be able to guarantee that the data is correct. And you know, for us, we've implemented serializable isolation, which is the highest level of isolation in a database, so that you can actually guarantee that, you know, when a record gets written in New York and the same record gets written in Singapore, the right data is gonna live after those two transactions execute. So you don't get any sort of graft or like dirty read or phantom read issues that you might get with a casually consistent database. So for Cockroach, you know, we fit this new world. We are distributed at our core, and honestly, it's why we're talking. It's why we're on the phone with my friends at Red Hat and OpenShift, because it absolutely just it fits. And this cloud neutral approach, which I think is another benefit of going down the path with something like Red Hat. It's you know people talk about being cloud neutral, and you know why would you want to be multi-cloud or hybrid cloud? And I think it's less about lock into a particular cloud provider. I think it's about freedom. I think it's about, you know, having the liberty to be able to architect what you want with the services that you want to use, and using something, you know, like OpenShift, which is independent, which has always been independent, which has been open source and kind of this world. I think is another kind of key value point here as well. So.
And Jim, seeing as we're all good friends here, I wanted to draw your attention. There are a couple questions in there you might want to address, or maybe you want to save till later.
Okay, let me see here.
I put them in the chat down at the bottom.
Okay, let's see here. Yeah. So do you have benchmark read-write metrics comparisons between Cockroach and Timescale DB? Actually, we don't actually benchmark ourselves against Timescale, and that Timescale is more of a time series database. My friends over there, another New York company, you know, they're being used for very explicit purposes. Great database for time series type database too. And you know, if you're doing things like running Prometheus, you know, running that on a Timescale, something like that's kind of interesting. But we don't run benchmarks against them. We do publish all of our benchmarks publicly. If you go check out our documents, our documentation is great. There's actually a performance section that actually outlines every benchmark we've ever ran. So, and we run benchmarks every night. Our ultimate competition is the speed of light, I always like to say. So.
Yeah.
Go on, Stefan. Did you?
No, that reminds me, I used to work in networking, and core router people say exactly the same thing. Speed of
Right.
light is the #1 limitation.
Yes, yeah, and that's right. And especially when you're starting to deal with these global environments. So, and on that point, somebody was asking about, with multiple write nodes, how is consistency maintained in the database? Now, without getting too deep into how transactions work, and we just had a webinar last week where we had one of our engineers explain this in some great detail if you're really interested. You can also look at our documentation. There's actually a section called Life of a Transaction, which goes into some really gory, great detail in this. We use some technologies. We use MVCC, and then we also use something called Raft. And Raft is just a distributed consensus protocol that allows us to basically piggyback on top of to do lots of things. In fact, our Raft implementation is used upstream with etcd as well. So it's some pretty complex distributed systems technology. When you write to a database on there's a thing called quorum. Data in CockroachDB is actually written 3 times. Every time you write a row, it's written 3 times. And we have to guarantee that 2 of the 3 writes are committed before that transaction is committed. And that's really the trick behind how that actually works. It's quorum writes, really. And so, but you can do that everywhere across the entire planet. So if you want more information, without getting too deep into that, I do want to bring Stefan in and talk about, what kind of things people are doing with this. We have lots of more information around that, but it's extremely interesting. So, and then there was also a question about ML, correct? I think so, Mike, right?
No, it was about, is it possible to set up and run CockroachDB in a closed environment or private cloud running OpenShift with no connections outside?
Yeah, you bet. Yeah, I mean, unless you need to connect to nodes that are outside. Yeah, I mean, I've spun up nodes, I've spun up clusters here on this laptop, right?
So as long as you can install your OpenShift in a disconnected mode, anything that comes with an operator, the likelihood you'll have some extra steps because you don't have connectivity, but yes, you can set it up.
Yep, that's right. So, I think being cloud native and building on these cloud native principles really opens up a lot of things such as this. I think we've learned a lot over the past couple of years to actually, deal with these sort of these difficult deployment type models. And I think, those that are actually developing and architecting to be cloud native, think about these things, because the cloud can be as small as 2 machines. It could be as small as this machine running right here. Right. This MacBook. Go on.
In fact, that's exactly one of our challenges lately, and we've been tackling it by making it available in smaller and smaller sizes so that people can experiment and sandbox and so on. So yeah.
And that's right. And when you write against the database, if I'm going to have a cloud database, so that better be a little app I run on my laptop, because if I'm a developer, I don't want to write against an emulator. Like, that doesn't make sense to me, right? Like, I want to write against the database because you never know what's going to be different once you get into production. Because we all know production introduces lots of complexity. So I find it to be, architecting to be truly cloud native, and a cloud being as small as 1 single box, I think is actually really, really critical. So that's just my opinion. But then again, I work at Cockroach Labs, right? So
yes.
So we answered this. I think my slides were a little bit out of order. Ultimately, like I was saying, CockroachDB delivers cloud native distributed SQL, right? This is standard, SQL. So we are wire compatible with Postgres, so it's going to work with all that. We implement a large amount of the syntax as well. We get this question a lot. 2 things that we don't do in Cockroach. We actually have not implemented stored procedures. It's kind of a little bit of an anti-pattern as we emerge and move into the future towards microservices. But I think you can get around that with doing things like actually implementing things as microservices. And I think, net new applications that are being deployed and built on OpenShift, move towards this kind of architecture. And so it's like the one area that I think people, think about with us. But this is effortless and elastic scale. It's spin up a new node, point at the cluster, it deals with everything. This does provide, our name, Cockroach. People ask us, oh gosh, why'd you get this name? People love it. I've become quite used to it. I love it, honestly. But it was
I have to say, the first time I heard it, I immediately knew what you guys were trying to get at. So I think even though it has a funny connotation, it makes sense based on how you're designed. And if you know what that implies, yes, absolutely.
Yeah, and it comes back to this kind of bulletproof resilience. It's really hard to kill. And think about Kubernetes too. Like, and so, we have a demo with OpenShift and CockroachDB. In fact, the first time I ever saw this I think it was at OpenStack Summit. God, it was like in 2018 or something. And so we had Red Hat and we had CockroachDB and we had Kubernetes, and I was at CoreOS at the time. And we had like 8 people up on stage, and each one of them representing a server, each one of their laptops. And we would kill a server, and we would show that, yep, every request would still be, accessed. And we would kill like 3 servers or 3 nodes at once, right? And there's no performance degradation. You just really can't kill it. And any, and so that's the beauty of what we're doing here. So, so let's yeah.
3 more good ones came in, I think, if you want to address those or wait till the end or.
Yeah, sure. Mike, do you want to just throw them at me, buddy?
Okay, sure. No,
this is awesome. I like having you here.
You and Stefan were on such a roll, but this one's really interesting, I think. So is the underlying cluster architecture based on a concept of a single cluster with geographically distributed nodes hosting CockroachDB pods, or multiple geographically distributed clusters with nodes hosting CockroachDB pods?
So great question, and all of the above. We've actually run multi-region Kubernetes, and actually we've seen, it's not the easiest pattern to go about, but deploying a Cockroach database across multiple Kubernetes clusters is definitely a possibility. And so it's kind of a little bit of both, I think. Stefan, I don't know if you want to jump in there.
Well, so I'll be honest with you, we tend to caution people about having distributed clusters across regions where you might have connectivity getting in the way. It comes down to etcd, which was mentioned by Jim at the beginning. The control plane has a very hyperactive, like it's a squirrel on sugar, trying to make sure everything is running, all the plates are spinning in terms of Kubernetes. So we tend to tell people that it can become dangerous if you don't have the perfect connectivity. But that said, this is a different layer. From a Kubernetes layer, we prefer at OpenShift to actually have it as centralized as possible, but definitely having pods that are communicating for CockroachDB on top of that is distributed among many. That is what we like. We like the application side of the resiliency. We like it when it's kind of the shift left mentality, having the developers develop an application that understand that things underneath may not be magical and capable of handling everything. They have to have some self-sense about how the universe is working around them. So we prefer having applications designed that way because they tend to prove to be more resilient. And I would consider Cockroach to be among the most resilient in its design.
We got 2 more good ones here. Well, that's good, but what happens if a node is?
One second, Mike. 1 second. Stefan, you said something really interesting there too. It's like, yep, at the local layer, within an AZ or within, one region, whatever that is, running a Kubernetes cluster, it's pretty well understood. Doing multi-region, tough, man. Like it's networking, it's security, it's the connection itself. If you can actually do that, but then actually layer up, go to the application layer and make sure the database is actually dealing with this resiliency, as long as there's connection between nodes of Cockroach, we're in good shape. So you actually, you remove you can actually get this sort of like global reach through multiple different regions at the application layer. The application layer being really kind of studied by the data itself, and we see that pattern more and more in some of these complex situations, and that's why I kind of said a little bit of both to that answer. So I just wanted to clarify that one thing. So sorry, Mike.
No problem. Well, here's the other one. What happens if a node is online and a transaction occurs on the other node? When the offline node becomes online, will it be in what state? What will update its data?
Yeah, so again, this comes all back to transactional consistency in Cockroach, and it really comes down to quorum. And so you have to have 2 out of, if you have a replica, if you set your replicas to be 3 within a cluster, then 2 of the 3 have to commit. So nothing's going to commit unless that can happen. And ultimately, there's something, if you're really interested in how these distributed consensus stuff works, I would highly recommend reading about Raft, R-A-F-T. It's a distributed consensus protocol. It's pretty awesome. And so there's something called a Raft leader. We call it a leaseholder. It's the ultimate ruler in terms of that range of data, or that replica set. Think about it as a row of data. The mic weight row in the customer table. There's actually 3 copies of that data on 3 different nodes within Cockroach. 2 of 3 of those have to commit before the transaction gets committed. So things offline, things online, it really depends on what's happened. Now, if something goes offline and it's offline for 30 seconds, we can actually consume that issue. What happens if things go offline for longer than and you can preset this, basically that range, that replica set will just go away, and Cockroach is smart enough to understand to actually rewrite that data on other nodes so that I can actually get quorum. And so it really comes back to quorum and this like 2 of 3 or 3 of 5 being written depending on your replicas. And that's really what allows us to actually survive some sort of failure of a node from a transactional consistency point of view.
There was one more, then I'll let you get back to it, but how does Cockroach distributed SQL versus Microsoft container-based SQL compare? Microsoft Container SQL runs on top of a platform abstraction layer. Linux containers are similar.
Yeah, I'm not real familiar with Microsoft container-based SQL. I am familiar with, SQL Server and how that runs. I'm also familiar with, I know there's Cosmos DB within the whole Microsoft offering, at least in the Azure side of things. And Cosmos was architected with a lot of the same sort of things. There's a lot of the same sort of principles that Cockroach has. Again, this is somewhere where say what you will about Microsoft. Microsoft is really interesting in that they do realize that they had this huge market in SQL. It's the number 2 relational database on the planet. It's everywhere. But it's not really built for the modern cloud environments. There's going to be an end of life for SQL Server. There's going to be an end of life for Oracle, y'all. And so I think Microsoft is smart enough to understand that to re-architect this actually makes sense. And so they went down the path of building out a distributed database as well. And so their architecture, similar in many ways. And so I think it's interesting from that point of view. It is tied to Azure. You can't run it everywhere like we're talking. I can do multi-cloud, just like OpenShift can be multi-cloud, right? And so there's lots of different reasons. I think SQL coverage is, look, I'm no expert. I will definitely say there's a lot of really cool things about that database, but I'm not sure if I answered it completely because I'm not sure I'm totally familiar with the Microsoft container-based SQL. In particular, I do know those other 2 solutions though. So,
right. Yeah, well, there was one long one. I'm sorry. Go ahead, Stefan.
I can only speak to the fact that Microsoft spent a significant effort to move MS SQL to Linux container. It's certified on OpenShift, and I can speak to the fact that they are doing all kinds of interesting things on the AIML front because of their database. But where it runs and where it's certified, so far I've only seen it in Azure personally. So that's a statement.
Interesting. Yeah. Well, look, you're going to choose the right tool for what you want to accomplish. For me, I joined Cockroach because I believe this architecture is correct. Getting consistency. A lot of the questions here. We had a couple of questions about actually consistent transactions in global deployments. In a single data center, consistent transactions are. I'm not going to say they're easy. They're a lot easier. Getting consistent transactions in a global environment, delivering, sub 100 millisecond latencies to every single person on the planet, that's just going to be really difficult to do out of a single region because, again, the speed of light, right? Like, so, I think as we see, 5G start to take hold of the way that we think about our systems and applications over the next couple of years, these are some of the things I think are really going to be extremely difficult. And the geo-partitioning, being able to tie data to location is another one of those things. It's, these are not easy things to solve. So, cool. All right. So, Stefan, we have 10 minutes to go through our yesterday when we were preparing this, Stefan and I actually spoke through this next section. We took like about a half hour. We could have spoke for like an hour and a half.
Easy. So we both are quite passionate about this, but I think I think one of the things about challenges is that having a background with large distributed systems myself, I think the #1 challenge that most clients face is that if you're going to build your own way of storing information on a large platform, you're actually going to spend time figuring out how to spread out the work among the worker nodes and then collect all the information, and bottlenecks will abound everywhere. And in essence, CockroachDB having no single node to write to, but any of the nodes that are part of it can handle that transaction, is essentially what I would have loved to have 20 years ago when I was working in this directly. So that is a big problem to solve, even in a local data center, even ignoring the beauty of the fact that this could be across the entire planet. And the other one, and I'll turn it over to Jim for his points, is
so
that
bottlenecks #1.
yeah, bottlenecks. Yeah. The other one is, for me, essentially the fact that we now have applications that are having to think through really critical knowledge of how the data is manipulated. It may seem odd to say this, but even though we are used to databases, we're used to databases in a traditional sense, where a single node or a cluster that only has one IP address or something traditional takes care of it. That's not enough going forward. When we're scaling microservices to tens of thousands of nodes or pods or etc., this gets a little hard. So it's not just a scaling aspect, is you no longer as a developer have to look for a library that does things for you. You can trust the fact that this is a trusted pattern, it's been implemented and it's been tested to work at scale. So it's no longer dependent on you to codify something that can throttle itself, that can handle it. No, you apply it to the existing platform and it gets it done.
Yeah. I will confirm both of those challenges. I think the bottleneck thing is definitely something like not having a single write master, for a database. That's always going to be a problem. And how do you actually do that globally for the latencies, right? I think that's definitely a big challenge we see people dealing with this privacy and having data reside in certain locations. That's a really big problem, and even getting even more difficult to solve, I think.
I'd agree.
Yeah.
I think open banking in Europe and potentially coming to, for example, Canada, like myself, and other places, the idea that you now have to be able to shard information out to make it efficient and yet maintain the whole consistency, those are challenges that are best left to people who've already solved the basics. So standing on the shoulders of giants.
Yeah, and you're relying on best practices to actually make that happen, and developers to actually codify it into the application. Why not just let the database deal with that, right? And so that's one of the big problems. I think there's a big meta challenge, and it's basically this move to the cloud. And look, I'm a CTO, and I've said let's move to the cloud. Let's go use Kubernetes. Why? Because I want to actually get efficient utilization of all this hardware and everything that I'm using, and that's why people are using Kubernetes. It's great. It adds complexity around scale. It adds complexity around, having resilient systems. It really does, because we don't have that expertise. Let the technology deal with that. When you put legacy tech in these new environments, you're actually asking for complexity. Finding tech that was actually purpose-built and architected for these new environments is a different story, because it was architected with this stuff in mind. I think that's one of the bigger challenges too. It's like, yep, oh great, I'm in the cloud, now what, right? Oh gosh, I have this problem, right?
I mean, that you basically also summarize what OpenShift is all about. I mean, we are not just Kubernetes, it's not just a control plane. We understand that just launching the applications and making sure they run is not enough. You have to have the entire ecosystem around it, both our own and the ability to have partners bring extra values to it. I mean, there are other pieces of the puzzle that might have to come from somewhere else. So the whole concept of the operators and the entire operator hub, etc., was created specifically so the clients can basically stitch together their solution, leveraging as much of the platforms and technologies that we can provide, so they can focus on essentially application and design that is business specific to them.
That's right. So, hey, y'all, there was a lot of questions that we got. We got through a couple of them, and we're going to get through everything. We will definitely send answers to everybody as well. I wanted to throw one last thing to Stefan before we kind of start to wrap it up. I got about 5 more minutes, but what is the level of investment that people should be considering when they start to go down this path? What are all the gotchas that I think that's a good way of putting it as well, Stefan, that people should be looking out for?
Well, first and foremost, they need to get comfortable with the idea of containers, the basics, the very basics of it, and then make an investment in both people and process that allows them to leverage it, because these are technologies that require, in the simplest terms, a small lab or a sandbox where you can actually allow developers to try all the options and see and give operators all the options to also look at it, so they understand that they will also get the tooling to go with it. And I think that's part of the investment. We call it DevOps, DevSecOps, however you want to look at it, but you want to basically enable these folks to try things, and everyone in the organization to get a sense of comfort that this is not an immeasurable task to handle. And on your side, in Cockroach Labs, what do you think is the big piece?
Yeah, it's funny enough, like understanding these distributed concepts, I think is kind of actually paramount to understanding how the database works and what these things are. Because ultimately, when you deploy a database, I don't know, when I've actually spun up MySQL or Postgres, I just think about the schema and I'm like, okay, good to go. You kind of have to, you don't have to just think about the logical data model. You have to actually think about physically where that data is going to live, because you start to want to deal with things like, what do I want to survive? Do I want to survive the failure of server, AZ, or region? Like you gotta, and then you gotta start thinking about latency too, right? And so there's this physical access to data that I think becomes really important. And I think the investment into understanding what that actually means for you and your application is important. And then the other side of that is developing the expertise in-house around Kubernetes and OpenShift and around things like Cockroach Database is just really critical. This is all open source software, so you can start today and you can start to go play with these things. But understanding it from an operational point of view is just really critical. Bringing new technology and new paradigms into your organization is not simple. It's risky, and we totally understand that. And so, we go to great lengths to make sure our docs are right and to work with you. And that's why you go with, companies that do understand this, because we actually are there to provide the expertise. Like we have Slack channels and we have documents and all these things. And I think that's one of the reasons why, partnering with somebody like Red Hat, who understands you and your organization and the challenges behind new technology and building up the operational expertise. I think operational expertise is one of the big ones, right, Stefan?
Absolutely. And I can also give a shout out. I mean, there are people who like to learn in class. So our own training organization within Red Hat, with the certification that can come on top of it, are well known worldwide. But we also have noticed that we sometimes need to kickstart these kind of behaviors. So Red Hat has an Open Innovation Labs organization where we essentially take a business sponsor and the technical team, both from an engineering and operations and development, and bring them together and go through an exercise of building a minimum viable product. And during that process, having them learn what the technology can do for them. So yes, it definitely, there are many ways of achieving success, but there has to be some commitment to time and people to be able to learn it and get it comfortable.
Dude, it is always people in the end.
It is.
It really does come down to this operation, and how successful you're going to be. It comes back to like how great you and your people are, and how well you are. Look, we've done lots of things to integrate these two things to make it as easy as possible. You better believe it. Like,
Absolutely.
In this partnership, and to me, it's one of the most important partnerships we have, because I think it's, this is just, like I said, this is chocolate and peanut butter. This works really well together, right? So, we can simplify it as much as we can, but getting the right people involved and having that expertise is just huge. So, Stefan, I got to wrap this up because I know Charlene's going to come in here in under a minute. Thank you for doing this with us and having us. Mike Waite, I know you're still on, and thank you for having us. It was just really, really an honor to be here with you guys. So, and I hope everybody on the show stayed around, because our conversation was great. We have really good retention here. But also, there's also the Amazon gift cards. So I know we're at the top of the hour, at the end of my time. So again, Stefan, thank you very much.
Thank you.
Mike,
thank you. It was a pleasure.
Go on, sorry.
All right, guys, I just wanted to break in and let you guys know that yes, we are going to be doing the drawing for 6 $200 Amazon gift cards. I'm so excited about that. But before we do that, I do want to remind the audience that today's event has been recorded. So if we didn't get, I'm sorry, so if you didn't see all of the webinar, or if you just want to watch it again, you will have the opportunity to do so. We will be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, also, yeah, we did have a ton of really great questions. If we didn't get to your question, please know that the folks at Cockroach Labs and Red Hat will be getting a copy of all of the questions that came in. So I'm sure they'll be more than happy to follow up with you offline post-event. All right, so without further ado, let's go ahead and do the drawing for the 6 $200 Amazon gift cards. Our first winner today is Kier M, and it's K-I-E-R. Congratulations, Kier. Our second winner is Linda M. Congratulations, Linda. Our third winner is Alan S. Congratulations, Alan S. Our fourth winner today is Ryan S. Congratulations, Ryan. Our fifth winner is Victor C. Congratulations, Victor. And our final winner today is, drum roll, Andre P. Congratulations, Andre. Now, the folks at Red Hat will be getting in touch with you via email to get your Amazon gift card over to you. So please look out for an email from them. Meanwhile, I want to thank Jim, Stefan, and Mike for being such great hosts at today's webinar with such great information, lots of interesting conversations. So really want to thank you guys for your time and your expertise.
All right, thank you. Thank you for having us.
All right. I want to thank the audience also for joining us today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.